Hello. To your attention is offered a report on the topic The Diagnostics Methods for Modern Communication Tools in the Armed Forces of Ukraine based on Neural Network Approach. The authors are presented on the slide. In recent years, the Armed Forces of Ukraine have been expanding and improving the system of communication and the automatic control of forces. The requirement of reliable operation of electronic equipment in the system of complex automation of control processes with the use of complex multifaceted systems communication on automation tools is especially acute. Therefore, the development of new, high-precision and reliable fault-finding methods is becoming increasingly urgent. The purpose of the article is to increase the efficiency of the diagnosis of communication and automation tools by using a basic method of the neural network tool to assess the reliability and ensure the guaranteed quality of operation of means of this class. A variety of research methods can be used in the diagnostic system, which include theories of graphs, decision support systems, fuzzy sets, neural networks, multi-criteria optimization methods, expert methods. Figures 1, 2, slide 2. The method of expert evaluation gives an objective description of the qualitative and quantitative aspects of the object for forecasting based on processing and analysis of a set of individual opinions of experts. Neural networks and fuzzy logic are universal approximations of complex, non-linear functional dependencies in many intellectual cybernetics problems. Figure 1, slide 3. The main feature of neural networks is their ability to learn, which is implemented using specially designed algorithms. The analysis of the literature showed that the use of neural networks for the diagnosis of communications, for example during routine of technical maintenance, repair, as well as in a state of continuous operation, is today a poorly understood and relevant direction which will allow to solve this problem. To solve the problems logically, it is sufficient to use one of the following functions. Slide 4. As an example, a neural network is built to diagnose communication equipment as an example of constructing a network for a task. The method of support vector networks or tracing is used during the construction. As inputs, standards working effects are used, those that can get on the device during its intended use, and those that are its main output parameters. You can also use specially generated test effects. At the output layer, the expected response to the defined input standard is formed. Take, for example, the neural network shown in slide 5. Suppose that all the same neurons perform a single transfer function, and that the scales and threshold realize equal and general capabilities. We introduce the transverse function of an arbitrary jth neuron with the number of inputs m. See equations on slide 5. Based on the calculations for the construction of the network, we compose a table 1, slide 6, which reflects the correct operation of the network, making different decisions. Analyzing the terms of the table, which correspond to reliable situation, it can be seen that the maximum excitation is determined correctly enough. This allows us to assert that the neural network designed directly for the task is built correctly. Conclusion, slide 7. Technically, the process of diagnosis of various communication and automation tools can be implemented by a single measuring and diagnostic complex based on a personal computer. With a switching device that connects the outputs of the equipment to the PC input, the status recognition process takes seconds. The results of the construction of a neural network for solving the problem of diagnosis of modern communication and automation tools are given, which will allow reducing the time for conducting technical maintenance and the number of measuring instruments involved. In the future, it is necessary to create a single package of applications for diagnostics of different types of communication devices based on neural networks, as well as a switching device by which the outputs of the equipment should be connected with the output of the PC of the operator's workspace.